Hey guys, welcome back to electronicsinnovation.com. Welcome to series of videos on sensors. In the previous video, we have interfaced this MAX6675 sensor with Arduino Uno and displayed the temperature data on LCD screen. In this video, we are going to display the same data on OLED screen. In the next video, we will perform durability or capability testing for the sensor to determine the maximum temperature this can measure. Then after, we will interface the sensor with ESP32 and ESP8266 modules and display the temperature data on simple web server. So without wasting time, let's get started.
PCBWay.com is one-stop solution for PCB prototyping, manufacturing and PCB assembly. Along with PCB prototype, PCBWay is also making assembly stencil within one-day production time. If you are using assembly components on your PCB, you should have this assembly stencil. You can get it easily from PCBWay.com. Just choose stencil type, size, stencil side and quantity. Then click on quote now. Check other advanced parameters here, then calculate. You can get it at $15, which is the best price in the current industry. Select the shipment method and complete the order. Required components are breadboard, Arduino Uno board, 16x2 LCD screen, OLED display, sensor breakout board with MAX6675 IC, K-type thermocouple sensor with the probe, screwdriver to connect the sensor probe and breakout board. Finally, a bunch of connecting wires to interface all these modules with each other. Here is the circuit diagram to interface MAX6675 and OLED display with Arduino Uno board. After all connections, the circuit will be something like this. Arduino Uno will read the data from the sensor and print the same on OLED screen. Coming to the programming part, here is the code to interface MAX6675 with Arduino and print the sensor data on OLED screen. This code will be available on the project page, which is mentioned in the description below. These are the libraries we are using. Out of these 4 libraries, y.h is pre-installed. You don't have to install it again. The rest of the libraries can be installed directly from the Arduino library manager itself. Go to the library manager, type MAX6675. If you followed the previous video, you will get it as already installed. If you haven't installed it, you can install it now. Repeat the same process for Adafruit GFX and Adafruit SSD1306 libraries. Creating a display object for SSD1306 and passing screen size and reset pin as parameters. Declaration of sensor pins. Data output as 8, chip select as 9, clock as 10. Creating a MAX6675 object and passing pin numbers as parameters. Coming to the wide setup, initializing serial monitor at 9600 baud rate. Initializing display with an object and passing I2C address and clearing the OLED display. Coming to the wide loop, reading sensor data and storing into the variables. The temperature in Celsius format and Fahrenheit is being stored in the values T and TF respectively. Then printing the same data on serial monitor. Before printing anything on it, clearing the display. Then printing the temperature in Celsius format on the OLED display using these lines. Printing the temperature in Fahrenheit format on the LED screen. Now this code is ready to upload. So let's upload the code to Arduino. Connect the Arduino Uno with a laptop and check the uploading configurations, board Arduino Uno and select the right port. If everything is okay, upload the code. After successful uploading, open serial monitor. If the sensor is working, you can see the temperature data on serial monitor. You can also see the temperature data in both Celsius and Fahrenheit format on the OLED screen. The temperature will be updated for every 500 milliseconds. Now it's printing current room temperature. Let's increase the temperature at thermocouple and see what happens. So As you can see here, the temperature on the OLED display is keep on increasing as I have started heating the sensor knob. I am impressed with the performance of this sensor because the sensor is very good at giving fast readings. So that's it for this tutorial. This is how we can measure the current temperature and display on the serial monitor as well as OLED display. This is how we can use I2C OLED to eliminate 16x2 LED messy connections. In the next video, we will see what is the maximum temperature this sensor can measure. See you soon on the next video. Bye bye.